Hello and welcome to Nikolai's genetics lessons. Couple days ago I got a question from one of my subscribers, and here is a problem. Add a linear line of best fit to the most appropriate data on the graph and show the equation of the line. And here is data. This column distance migrated in millimeters, and here is DNA size. Basically we asked to make a chart that may look something like this, and we may get points here. Probably it would be organized like this, and we have to find a line, or points can be organized like this. It shouldn't be a perfect line. If we would connect all the points, we would get line like this, but according to our problem we have to find some position that would be in the middle of all lines, and this is how we would make a perfect straight line. And for such lines we have equation where y equals to mx plus b. M here would be slope. We find this is y2 minus y1 divided by x2 minus x1. Or we also can say that this is rise over run. And b here is y-intercept. Or basically we have to show where on the y-axis this line would cross. So we have to find the point, or say this line where it would cross y-axis. So we have to get such graph, and we have to get some formula that would describe this line that we are going to get. In order to solve this problem, I would use Google spreadsheets. First you have to go to Google Docs and then choose Google Spreadsheets, and here is the first slide. This is what you're going to see, and as you see I already completed these two columns. First is distance, second is size. So this would be x-axis, and this is going to be y-axis, and this is interface that you can see. It resembles interface of the Excel, but Google spreadsheets are free, so I highly recommend everyone use this online application, because this is free and because you can share data, you can work in teams, and this is very simple to use. So on the next slide, as you see, I highlighted these columns. Just click and drag, and now I am clicking on this button you see here, or you can right click and also choose charts. And on the next slide you would see that after you click that button, this is what you would see next window. And now we have to click this button, chart types, and when we click this button we would see new window, and here we have to choose scatter form. And as you see here on the right, all the information now is organized in dot form, and here on the y-axis we have the size, and here on the x-axis we see the distance that DNA traveled. Now we have to find the perfect line that would be like a compromise between all these dots, and it would be much more time consuming if we would do it manually, but with the help of this program this is just a matter of one click. And you have to choose customization. You have to click this folder, and here you have in trend line have to choose linear, and now you would see the line that would be like a compromise between all these dots. And on the next slide, and on this slide you can see if we choose show r squared, we can see deviation from the perfect line of our dots. So as you see, deviation is not large, it is close to 1. So if we would have, instead of 0.95 here, if we would have 1, then this means that all the dots would be on this line. But the smaller this number would be, that means that deviation from the perfect position on one straight line would be greater. As you see, here we have about 5% of deviation from these points to be on perfect line. And on this slide we are still in customization, and we choose label, and we choose use equation. And now we have our equation of this line. So y equals to minus 36.93 multiplied by x plus 1808.45. And this is going to be our equation that describes our line. You may customize how your graph would look using this customization form, and if you scroll this bar you would see many other things that you can adjust, like name of the of your picture, of your graph. You can choose names for y-axis, x-axis, and also can adjust colors and fonts. And basically now we just have to click this insert button, and this is finally what we would see. Here is our original table, here is our graph, and here our formula that describes this line, and this number, that is 1808.45, is b in our formula. Once again, y equals mx plus b. So this number describes where this line crosses y-axis. And m in our formula is a slope. So the other name of this equation is a slope-intercept equation. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any, and see you in the next video. Goodbye.